Okay, good afternoon. How are you?
Good afternoon.
Everything's okay so far?
Yeah.
Okay. So how many of you have is from IATP? Can you please raise your hand? Okay. So almost all of you. Okay. How about GE? Okay. So it's okay for me to, because this is a EMI course, right? So I'm gonna introduce in English, okay? Okay, and I guess there are some other students who haven't come to Taiwan yet, okay? But it won't be a problem since we will record, okay? The TA is recording the video now, and I'm also recording myself, okay? So like later on, maybe I can use it if I get quarantined, okay? Let me introduce myself first. Okay, my name is Mong Chai from the Department of Material Science and Engineering. Okay, I'm currently an assistant professor. Okay, I've been to NTUST for 4 years. Okay, for 4 years, and some of the GD seniors. Okay, but I guess we won't have any seniors here because this course is considered relatively easy course. So I think nobody will take this course again after the freshman year, okay? Because some of the courses from GD was taught by me, okay? In like 2 or 3 years ago, including the material science, okay? If you belong to the material science, but I think there's also some students belonging to mechanical engineering for GDIP, right? The GDIP student. 你们有些人是机械的嘛？哦。Okay. So I know more the students in material science division in the GDIP program. Okay, and I was also what we call the homeroom teacher, or like a tutorial or a mentor for the GDIP student, okay, the 3rd grade and the 4th grade GDIP students, okay? And but I think too bad I cannot have the material science course for you, okay, since like last year, okay? But it's okay, if you want to know me, you can easy to make an appointment, okay? Just write an email or something, okay? And before we start, I want to briefly introduce myself again. Okay, I graduated from the Department of Material Science and Engineering in National Tsinghua University, which is in Hsinchu, right? Hsinchu. Okay, and mostly I work on the synthesis or growth of nanomaterials currently. Okay, but I think I will go to that later. Okay, and before I joined here, okay, before I graduated from NTHU, my thesis advisor, okay, moved to what is called the King Abdullah University of Science and Technology. Is there any student from IATP know where that is? No? King Abdullah University of Science and Technology. Okay, if you're interested, you can search it on the YouTube. Okay, it's located in Saudi Arabia. Okay, I think the facilities there are among the best. Okay, for the researchers. Okay, so and also the salary there was good. Okay, if you are a master student, you get like $20,000 per year to study the master. Okay? And if you are a PhD student, you get even more. You get $30,000 per year. Okay, for doing research there. Okay, and for postdoc, maybe more than $60,000 per year. Okay, so my advisor decided. I was co-supervised by a professor in National Taiwan University. Okay, so I have two bosses. Okay, and one of them moved there. Okay, so some of my group members also went there with him, And then before I graduate, I get some time to like travel there for 2 months before the oral presentation. Okay, it's hard for me to say no, okay, because that's before the oral defense. Okay, oral defense, but it's a quite good experience. Okay, because inside the campus and outside the campus are totally two different things. Okay, outside you just see what you see, like you imagine. Okay, like deserts and only those roads within the desert. Okay, you see lots of sand or and hot air, hot weather. Okay, but inside the courses, inside the campus, on campus, everything is well equipped. Okay, and inside the building you get air conditioner set at like 23 degrees Celsius for the whole year. Okay, if I want to go from building to building, okay, I can go to the basement. There are underground trackways for the students to go from building to building. Okay, so it's quite comfortable inside the university. Okay, so if you're interested in going there to study like master or further PhD, okay, feel free to contact me and I can share some of my experience with you. Okay? Okay, so let's go back to the introduction to the Department of Material Science and Engineering. Okay? So I know for the GDIP student, you have already selected your major before you came in, right? Okay, how many of you select in the Material Science Division for GD students? 材料的, okay, so I think I would expect like 10 or 12, right? Okay, and how many in the Mechanical Engineering Division? Okay, so for you is I think this hour's lecture is not designed for you because you have no choice. Okay. You just need to focus on what you chose before you enter the NTUST, okay? But for the IATP students, you haven't chosen your major yet, right? Okay. So I want to do a quick survey, okay? How many of you is more interested in, for example, mechanical engineering, or you don't know that yet? Okay, I think it's about 5, okay. Yeah, because I need to report to my chairman, okay? Okay, and how many of you are more interested in chemical engineering? Also like 5, okay. Don't lie to me, okay? Because at last I will ask you how many of you are interested in material science, okay? And there's another one called what? Civil engineering. 3, okay, and 5, okay. But I think there's around like 30 or 40 students, okay, for this year. So how many of you is more interested in material science before the talk? Okay, none? Okay, that's good. That means I have much space for me to improve, right? Okay, for me to improve. Okay, okay, I will report to my chairman that none of you is interested in material science. Okay. Okay, but anyway, people changes, right? So maybe after, I don't expect to like you change your mind after you listen to what I introduced. Okay, but maybe during your university college career, okay, you may like select some courses and you find it interesting, okay, it belongs to another field than the field that you are previously like more interested to, okay, and that's a good thing, okay, because you finally know what you like and you don't like, okay. Many Taiwanese students don't know what they are interested in. Okay, and I was one of them. Okay, when I was during my undergraduate study. Okay, Okay, so let me briefly go into this introduction part. Okay, so it will be a bit boring. Okay, if you just already decided what you are interested in. Okay, so but I will try to make it not as boring as it is. Okay, but it's quite difficult. Okay, the introduction of our department. Okay, the first of all. Actually, this is the history. You can see that mostly the Department of the Material Science and Engineering are new departments. Okay, probably there are MSc department founded back in like 1960 or 70, but at that time it's usually not called this name. Okay, it's usually called as like metallurgy or like fiber engineering. Okay, or textile. And sometimes it's called chemical engineering, right? Some material science and engineering department transform from the traditional chemical engineering to like a material science and chemical engineering department, okay? And I think this is due to the development of the, you can say the development of science or industry, okay? Because previously, the most common jobs, maybe like related to plastics or related to like chemicals or related to like gas or petroleum, right? Okay, but recently, especially in Taiwan, many people try to get into the semiconductor industry, right? So that's fine. Okay, if the semiconductor industry doesn't need any workers from material science and engineering department, okay, I don't think there will be any changing the name of those departments, okay? And so our department is just the same thing, right? Actually, our department was founded as four of the earliest department in NTUST. Okay, at that time it was called the textile engineering, and this is due to that at that time most of the jobs are provided by these this related textile related companies, right? Okay, and after 4 years it changed to fiber engineering. Okay, fiber engineering. And 1985 we started our PhD program. Okay, and the year 2000. It's changed to fiber and polymer, and then polymer at 2003, and 2005 we started international program, but mainly focused on master and PhD. Okay, because the university usually just offer the scholarship for a master and PhD. Okay, because research can like provide the publication, and publication provides what the university wants, okay, but that's another story, okay? And in 2010, okay, it's finally changed to what it is right now, Department of Material Science and Engineering, okay? So you may see if you know you have some like friends in other university, some of the material science department is called optoelectronic and material science, and some called chemical engineering and material science. Okay, but it's just if you look into the research field of the professors, okay, you may see that if it's called like chemical and material science and engineering, then the professors' research will be more related to chemical engineering. Okay. And if it's transformed from polymer, okay, there will be a larger portion of the research focused on, for example, the organic part or the polymer science part. Okay, so this is the case, okay, for our department. Okay, so currently we have 17 professors and 5 associate professors. Okay, and we have 8 assistants. Okay, including me. Okay, I'm one of the assistant professor in our department, and there are 3. Okay, actually we call it foreign project assistant professor. Okay, but for you, it's just like international assistant professor. Okay, because they are not Taiwanese. Okay, so they can offer some help. Okay, whenever there is some international student issues, or they can offer some courses related to the EMI courses. Okay, but for the local professors, okay, we are also asked to provide EMI courses. Okay, so both local professors and project assistant professor can offer the EMI courses. And there are 2 lecturers in our department. Okay, mostly for offering the lab courses. Okay, the laboratory courses. And there are 9 staff members. Okay, so the number of students, we have 88 PhD students and 270 masters. And then for undergraduate, 440. Okay, so the 55% of the students are undergraduate students, and 34% master and 11% PhD. Okay, and among them, more than half, I'm not sure it's more than or almost half, are, especially for PhD, mostly international students. Okay, mostly international students. Okay, let me briefly go on to talk about the research. Okay, the research. Like I said, our department was changed from polymer engineering to material science and engineering. So almost half of the professors are from the organic material division. Okay, and another half from the inorganic material. Okay, inorganic material, you could think of it as like metals, ceramics, okay, or some of the electronics. Okay, but after we go into the nanoscale of the material synthesis or application, it's no longer that clear. There's no longer a clear line between the inorganic and organic. Okay, many people try to use like hybrid strategy to design their material. Okay, so I think later on maybe we will not like do a very clear classification of who belongs to who. Okay, and we have another division called the material processing. Okay, this is due to that during the past we are called fiber or polymer engineering, and there will be some machines or facilities, okay, that is required to design in the factory. Okay, so we have 2 professors. Their expertise is in the, for example, the automatic processing. Okay, they try to their field is more related to like mechanical engineering rather than material science and engineering. Okay, but I think after like the 2 professors are retired, we will hire new ones and like more related to organic or inorganic ones. Okay, so maybe later on it will become only 2 divisions instead of 3 divisions. Okay, in our department. Okay, so first let me introduce some of the research and professors in the organic division. Okay, we have almost 10 professors. Okay, working on the research related to like biomedical. Okay, biomedical application has become one of the main focus in our organic division. Okay, because not many people want to do those traditional research related to like textile or fiber. Okay, but bio has always been brought up to people say that it's the future of like the material or the related development, okay, in the industry, especially in Taiwan, okay, apart from the semiconductor. Okay, so our department recently hired like 2 or 3 new professors. Okay, their main focus are all belong to the bio-related research. Okay, you can see there are also some semiconductor-related application. Okay, organic semiconductors. Okay, but this may more related to the research only. Okay, in the industry, people still usually focus on using the inorganic material, especially as silicon, okay, for the semiconductor, as semiconductor materials, okay? And we have some professors working on, like, as you can see, I talked about earlier, organic, inorganic nanocomposite, okay? And some like green composite, organic solar cell, okay? Micro and nanocellular foam, okay? Foam. And then we have a professor working on interfacial engineering, low dimensional nanomaterial and flexible devices, okay? Flexible devices, you can try to come up with some like wearable electronics, okay? The electronics that you can wear in, on your clothes, right? On your clothes, okay? And these are some new professors, okay? If you're interested, you can contact them, okay? Contact them. I think they are all very nice to get along with, okay? If you are interested in some undergraduate project, okay? Professor Xiao working on organic electronics, and James Lai, he has more than 10 years, I think more than almost 20 years experience as a professor in the University of Washington, okay, in the United States, okay, and he's working on some cancer biology in the point of care diagnostics, okay, this bio-related research, okay, and Professor Zheng collaborates with the hospitals to come up with some drug carriers, so materials for regenerative medicine. Okay, and Professor Lin working on some simulation project. Okay, and we have a very beautiful new faculty. Okay, come from the National Sun Yat-sen University in Kaohsiung. Okay, he just come this semester. Okay, he's working on the organic solid-state electrolyte. Okay, so that's about the research and the faculty members for the organic division. Okay, now let's go on to the processing. Okay, processing division. For the processing division, as I said, during the past we need to have some professor designing the systems. Okay, so Professor Guo and Professor Huang are two experienced professors. Okay, for doing the design of control system. And automation. Okay, I think this has become a quite important topic recently. Okay, because the automation and the AI related research has become a focus in the related research. Okay, but if you're more interested in this type, I would actually encourage you to like directly go for mechanical engineering because you will have more resources there related as compared to the resource in our department, okay? And we also have two professors working on, for example, the solid-state lighting solar cells and functional polymers. So one more related to organic and another related to inorganic material. Okay, so this is the processing division with only 4 professors, okay? And then this leaves the inorganic division left for me to explain. Okay, for the inorganic division, okay, you will see professors working on, for example, metallic materials related research, and also some like metallurgical thermodynamics, okay, or like semiconductor manufacturer. Okay, and also some like electrochemistry. Okay, electrochemistry is considered one of the topics in the inorganic division. Okay, in our department. Okay, and then we have some professors mainly focused on the material analysis. Okay, including the electron microscopy and some applied science related fields. Okay, so here you can see chemical materials, including fuel cells, lithium-ion batteries, and energy storage and conversion. Okay, and Professor Shi is currently our chairman. Okay, so I need to report to him that none of you is interested. Okay, later on. Okay, but I would expect that maybe like for the second year student, I think two of them selected material science as their major, and for the third grade, 3 of them selected, but they came to my class and saying I'm teaching too difficult. Okay, so maybe they will report to you, don't select material science. I don't know. Okay, so I will make it easier for them, so they can encourage you to select, okay, the material science as the major. Okay, and Chairman Shi is working on the ceramic-related application. For example, some artificial joints, okay? Also collaborating with hospitals, okay? And also Professor Wang working on the design of nanowire materials, okay? And this is me, okay? I will go through my research later if we have time, okay? So I'm not gonna spend too much time to talk about it right now, okay? And Professor Liang is I think he's below 30 years old. Okay, he's our newest hired professor. Also working on the metallic materials. He's doing carrying out like electro treatment for the metallic materials. And he's also teaching the material science EMI course in our department right now. Okay. Yeah, so that's about all the professors. Okay. And then additionally, we have 2 lecturers. One is Ms. Huang, and the other is Ms. Xu. They are mainly in charge of the lab courses. Okay, so our lab courses include metal, ceramic, and polymer. Okay, so I think Ms. Huang is more focused on the metals, and Ms. Xu is more focused on the polymers because she graduated from the molecular science and engineering department. Okay, and there's one specialty about our lab courses. Okay, so I think for lab 4 or 5, you get to use the 3D printers. Okay, in our 3D lab, and our 3D lab looks quite fascinating. Okay, I will just go directly to the 3D lab first. Okay, there's a discussion area. Okay, so people just students just always brought their snacks here, okay, to eat and discuss at the same time, okay. But this is separated, okay, so it does not affect the facilities, okay. We have a 3D printing training area, okay, because this is a qualified lab for the examination or the qualified for the national certificate for the 3D printing. Okay, so we have like over 30 3D printers available, okay, in this room. Okay, and we also have some more sophisticated 3D printers, okay, with TAs. Okay, so the TAs can help you if you have some like new design you can come up with, and you try to like print it out. Okay. Okay, so let's go back to the project assistant professor. Okay, is there anyone from Indonesia? No. Oh, one. Indonesia. So many. Okay, I'm shocked to hear that. You sure? You sure you're not pretending to be from Indonesia? Okay, okay. This is a professor from Indonesia in our department. Okay, so before he's currently teaching Calculus 1. Okay, so if you're an Indonesian student, you want to take Calculus 1, you can welcome. But it's all it has already passed the deadline for add and drop. Okay, so I'm not sure if you can. You are able to select his course, okay? But you still have chance because he also has Calculus 2, okay? So if you want to discuss with him in a more Indonesian fashion, okay, you are welcome to contact him, okay? And he also offered, I think he also offers the course for this program previously, but I'm not sure later on will he continue to offer this course or not. The thermodynamics of materials, okay? So every year maybe there will be like 3 students, 2 students selecting the material science major, okay? He will teach the thermodynamics of material for the IATP program, okay? And also he offers material science 2 in our department, okay? And is there any student from India? No? Okay, India, I think mostly graduate students. There are lots of Indian students from for our graduate, okay? Both for master or PhD, okay? So we also have an Indian assistant professor, and he's currently teaching more chemistry-related courses, such as Chemistry 1, Organic Chemistry, and Polymer Systems, and Physics and Chemistry, okay? Okay, this is another special one. Is there any student from Ethiopia? No? Okay, this is an assistant professor from Ethiopia. Okay? You know where Ethiopia is, right? No? Okay. You can come to me after we finish the course. I can show you the map where the Ethiopia is. Okay, it's in Africa.
Oh, Ethiopia.
Yeah, Ethiopia.
Oh, I know it.
Yeah. Okay. Professor Daniel, he taught, he's teaching the introduction to X-ray crystallography and diffraction. I think this is also for the IATP courses. Okay, both IATP students and MSc students are allowed to select his course. Okay, and also offering the physics of semiconductor material for the 3rd grader in the next semester. Okay, also collaborating with IATP program. Okay, so these are the 3 international assistant professors in our department. They are all graduated from our department as well. Okay, so they should know many things that you need to know when you are in Taiwan or in NTUST. Okay. Okay, so the next part will be courses and facilities. Okay, courses and facilities. So if I think mostly courses. Okay, the facility I put it in part 4. Okay, so for the material science major, okay, apart from the required courses in the 1st year, you need to take material science 1 and material science 2. I think both taught by Professor Deng, right, for the IATP. You already met her before? But I don't know her English name, I just know Professor Deng. Okay, Professor Deng. And for the GD, it may be taught by Professor Huang, right? Or Professor Jiang. Jiang or Huang. Or also Deng? Okay, never mind, it's not very important. Okay, so for both chemical and material science major, you need to select material science 1 and 2. Okay, but for material science major, we excluded the statics. Okay, I think before we have statics for the past students. Okay, but we remove that from our required course. Okay, if you're selecting a material science major. Okay, and also the graphics only for the mechanical engineering students. Okay, this is for your 1st year. Okay, and for your 2nd year. Okay, if you expect that you are selecting mechanical engineering, okay, you need to make up your mind because you need 19 credits, okay, for the 1st semester. Okay, but we are not the least, okay, we have 13 credits, okay, including the lab, okay, lab. Okay, so I think chemical engineering, will be the luckiest for the first semester in second grade, okay, because only 12 required courses, okay, and we will focus on the, I think engineering mathematics is required for all the major, right, in the College of Engineering, and also programming language is the same, okay, as the rest of the department, and we need, we are similar to the chemical engineering, we both need organic chemistry, okay, but we also need the organic chemistry too, okay, this is something different. If you are in IATP, I don't think you need, if you are in GD, I don't think you need organic chemistry too. It's not a required course for you, I think, okay? Let me know if I'm wrong, okay? Because based on my knowledge, the material science department student, they don't need the organic chemistry too. It's an elective, not a required course, okay? But for INTP, somehow it becomes a required course for the material science major, okay? And we also need the thermodynamics and the kinetics, okay? These are the two main topics, okay, if you're selecting the material science major, okay? For the thermodynamics, okay, you try to understand the properties of states, okay, in solid state or the liquid phase, okay, states and phases of material, okay. You try to control your process in order to come up with the phase you want for your material design, okay. And also the lab course, okay. And I think the lab 1 is mainly focused on the microstructure of metallic material, okay? So you'll need engineering mathematics 2 for the second semester in the second grade, and organic chemistry 2, mechanics of materials, and the polymer system, okay, polymer system. In the past, we also have polymer physics and chemistry as required course for students in IATP, but now we take it off from the required courses. Okay, because usually for the material science and engineering department, we don't have as much polymer-related course as the one we had previously. Okay, and in the third year, you are expected. You see, in the third year, in the first semester, the MSc become the luckiest one. It's only 7 credits required. Okay. And 2 of the courses, this physical properties, I will briefly explain it later. Okay, this is taught by me. Okay, I will briefly explain it later. What is it about in this course? And also the introduction to X-ray, crystallography, and diffraction. Okay, because X-ray is a very important tool if you want to know the structure. Okay, if you want to know what type of material you have, is a very useful tool in our department. Okay, and also another lab course with 1 credit. Okay, and in the third year, okay, second semester, we have characterization of materials as a required course, and physics of semiconductor material. Okay, this is quite unique. You see, if you go to the third grade, every department seems much more different. Okay, if you select mechanical engineering, you need fluid mechanics. Okay, you need a mechanical design. Okay, and these 2 will be very tough. Okay, if you are not very interested in these topics. Okay, but we are more focused on the semiconductor materials. Okay, so if you decided to go to the semiconductor industry, I think this is our department offers the best course combination design for you. Okay, if you're interested in going to the semiconductor industry. Okay, and in the first year, I think for every department is similar. Okay, the fourth year is mainly the special topics, means you're doing project in a lab. Okay, you can find a professor and do a project in their lab. Okay, in their lab. And some of the students can even find some internship. Okay, but if you want that internship to become your credit, okay, then the company will have to sign a contract with our department, okay, or the university or other department in the university. Okay, so far I haven't seen any international students selecting the internship and put it as the credit. Okay, they usually just simply go to some part-time job. Okay, but if you're interested in doing the internship, I will also briefly explain it later. Okay, you are also welcome to come and discuss. Okay, because I was in charge of the internship program in our department. Okay, so later I can show you some photos or the possible companies that if you're interested to do the internship. Okay? Okay, so let me briefly introduce what material science is like. Okay, you may have already seen this if you have taken the material science course. Okay, and if you are from a chemical engineering major, okay, you still need to take the material science course, right? So the material science course is just we start from the atom to the bonding, to the structure, and to the overall material design, to let you know that even the same element, you can see here, for carbon, it can be constructed as graphene, carbon nanotube, or diamond. Okay, what's different between them? You can see graphene is a conductor, right? And carbon nanotube, usually we consider it as a semiconductor. Okay, how about diamond? Okay, you don't expect diamond to conduct current, right? Okay, so for the same element, due to different orientation or crystal structure, okay, it can be used for various types of applications. Okay, that's what we want to understand for this course, okay, for the material science. And in addition, you can see, besides knowing the properties of material, we try to go one step further to know how can it be used. Okay, so you can see for these three figures, they are all what? Coke bottles, right? Okay, but you can see, depending on the design of the bottle, you can design into what? This is metallic can, right? It's either like aluminum or tin-based, okay, cans, right? You can also design it to become like ceramics. Okay, glass is one type of the commonly seen ceramic material, right? And also plastic bottles. Okay, and I personally like this one best because I think the flavor is best kept in this type. Okay, and I think normally people think this one is the most disgusting or not tasted well. Okay, among these three. Okay, so some people may even try to like put their Coke into a metallic cup or whatever before they drink. Okay, because probably there's some interaction between the Coke and your bottle to make you feel better. Okay, when you are drinking it. Okay, so this is how people try to do different design to approach similar application. Okay, but with some like probably you design it this way so you can like taking this while you're doing sport, you will not break apart. Okay, and so we try to understand why this material does not break apart. Okay, it is tougher than the ceramic. In terms of toughness, we mean how much energy we provided to the bottle before it breaks apart. Okay, but the glass, you would expect it to be stronger, right? So the strength is higher for this. Okay, but actually for this it is tougher. Okay, we would try to define those terms in the material science and try to characterize how it can be used in related applications. Okay? And I will not go very deep into this, but just provide you with a brief explanation. Okay, I want to, let me see if I can, yeah, I can want to remove the bottom part. Okay, so in material science, we focus on knowing the structures of the material. There are different types of structure, and different structure may contribute to different mechanical properties, or electrical properties, or optical property. Okay, any type of property can be related to the different structure orientation. Okay, and we also talk about a defect. Okay, the defect is not always a bad thing. Okay, without defect, actually, we don't have the semiconductor industry. You know why? Because in order to design semiconductors with the different conductivity, or more specifically, different mobility, we need to put impurities inside our material. Okay, by putting those impurities, we can effectively control the conductivity or the mobility. Okay, so we can come up with various types of electronic devices. Okay, and we try to explain the mechanical properties. I think for the mechanical engineering majors, okay, you are familiar with this type of figures, right? Okay, at first we have like elastic deformation, and then we go on to plastic deformation. Okay, and at a certain point you experience a necking problem. Okay, some part of the material will be the diameter will be largely reduced, and then finally diffraction. Okay, we try to characterize the relation between structure, between defect and its mechanical property. Okay, and then I think this is the most interesting part for me. Okay, because I like to see those disaster series of plane. Okay, and every time I see it, they put it under a microscope and say we have a fatigue problem, we have some whatever problem, right? Okay, so in material science, we try to relate those defects. Okay, defect can be like in one dimension, zero dimension. Zero dimension means point defect. One dimension means line defect. Okay, or two dimension, plane defect. Okay, we try to relate those defects with the failure problem. Okay, what type of defect can contribute to the failure, or some like corrosive problem. For example, if your ship sailing in the river or in the sea, okay, there's some salt within the seawater, right? The salt of seawater can also contribute to react with your material, okay, and make it more corrosive, okay? And for planes, you see why this is a Aloha airline. This is an airline located in Hawaii, okay? Hawaii is surrounded by the sea, right? By the sea, okay? So there may be more corrosive coming from the salt to affect your plane, okay? So whenever you're designing the plane or you're buying the plane or you're doing maintenance for the plane, you need to consider these environmental problems, okay? And finally, the processing of materials, okay? For metallic material, for ceramic material, for plastics, there are different processing methods, okay? This is about what we will talk about, okay, in the material science, okay? And then, I think we will, before I go on, I think we will have a 10-minute break, okay? After. Okay, so far is everything okay? Is it too boring? It's okay. If you feeling too boring, it's okay to take a small nap. Okay. And then, okay, so this is about my course, okay? Previously in the last hour we talked about material science, what it is about in this course, right? And in the third year of the material science department, okay, we will have a course related to physical properties of material, okay? But by physical properties, we don't mean the mechanical properties anymore, okay? For mechanical property, it's only focused in the first year material science part, okay? And also in the material science 2, okay, we will mainly focus on like diffusion, thermodynamics, and these, okay, the basics of electrical, magnetic, optical, thermal properties of material. Okay, so you will get to know that what are the difference in the physical behaviors between conductor, semiconductor, insulator. It's not just as simple as the current is large for conductor, the current is 0 for insulator. Okay, there are some physical models to explain this. Okay, and the physical models can help you to do further design whenever you want to come up with a new device or to improve the performance of your electronic devices. Okay? And also we talked about the magnetic properties. And the magnetic for material scientists, okay, is actually used in their daily research, okay, because in order to come up with an electron microscope, okay, we need to use, instead of a glass lens to focus the optical light, for electrons, we need to use to come up with some electromagnetic lenses in order to do the focus. Okay, we try to focus the electron beam into a specific position, okay, in order to come up with a high resolution image in the electron microscope. Okay? And also, this is more related to my research. Okay, we try to do some light-emitting materials. Okay, we use the light-emitting material combining with inkjet printer. Okay, to print out those letters. Okay, and if we put it in a UV box, ultraviolet box, okay, you can see the luminescent materials indicating those letters. Okay, and also there are other applications such as LED, light-emitting diodes, or the photovoltaic, which is also called solar cell devices. Okay, and also there are some thermal behaviors that material scientists may be interested too. Okay, for example, if you have a spaceship, okay, you need to design a heat shield to prevent those heat conducting from the back to the passenger seat. Okay, to the passenger seat. Okay, and there's another course called the material analysis. This course is basically explaining how we can do the transmission electron microscopy. Okay, but this mainly focus on the theory. Okay, so how can we, why this kind of image can help you to understand what type of material you have. Okay, this image, we can indicate the lattice perimeter. The lattice perimeter means the spacing between those planes in your material. Okay, and also the scanning electron microscopy can be used to observe the morphology of your material. Okay, and we talked about the X-ray diffraction before. Okay, the X-ray diffraction is like the DNA of your material. Okay, so you try, if you don't know what the material is, you try to use the X-ray diffraction. It will have certain peaks. And there are database for you to compare with the peaks you have. And it will automatically tell you like it's like 90% of like material 1 and like 10% of another material. Yeah, and so on. And also we also talked about the scanning probe microscopy. So you can see that this type of material is almost one atomic layer with only like 1 nanometer thickness. Okay, we try to use some scanning probe, okay, to scan it. Okay, and after we scan it, we can identify the height, actual height of the material. Okay, and we can also apply some like current or frequency to the tip. Okay, so actually, in fact, if you just simply scan it, you may imagine this may be only one material only, but in fact, there are two materials. Okay, one material at the outer part of this triangle, and another material at the center part. Okay, so if you apply, like, depending on the material, okay, if the material is conductivity at the bottom, at the surrounding, and insulating in the center part, then it can be identified by applying like a conductive current, okay, through your material. Okay, this is basically the concept for these imaging strategies. Okay, and in the semiconductor processing course, okay, this is actually a graduate course, but most of the fourth grade students in their last year, because most of the students, graduate students, go into the semiconductor industry, okay, in Taiwan, right? So in the fourth year, many students will take this course. Okay, we talk about the device design. For example, traditionally we come up with a planar field effect transistor, and then currently, like beyond the 5 nanometer processing, okay, we go for FinFET. Okay, FinFET. We try to provide a better control of the channel in the field effect transistor. Okay, and later on in the future, probably we need to come up with something called a gate all-around. Okay, you may see this type of these notations in the magazine, right? Okay, so we will try to, since these are all very new topics, okay, apart from the classroom lecture, we also invite the lecturers from the industry. Okay, the lecturers we invite are among these companies. Okay, for example, TSMC, SMO, Applied Materials, Garmin, KOA, Lam, and this company is like a consulting company. Okay, provides there are consultants in this company to provide some recommendations, okay, for the future development of these companies. Okay, so they offer some workshops or like discussion sessions, okay, for these companies. Okay, and also the packaging technique will be important, okay, for the next generation semiconductor device, and the processing techniques. Okay, this is a facility of EUV, okay, extreme ultraviolet, okay, and then for the ICs beyond like 5 nanometers can only be achieved with this type of facility. Okay, this is as large as the whole room. Okay, so if you're standing beside it, you look very, very tiny. Okay, in this when you are standing beside this system. Okay. Okay, so what else? Okay, as I said before, in the last hour, I talked about the internship. Okay, so for your fourth year, it doesn't matter what department you belong to. Okay, maybe you can have a chance to work, okay, in a local company, or even there are some students trying to find companies abroad, okay, for internship. Okay, but they still need to sign a contract with the NTUST in order to become accredited for you. Okay, and for the semester internship, I think there is a 9 credit course. Okay, and most of the students go for like summer internship for 3 credits. Okay, but I don't see many international students doing this type of internship. But because most of the traditional company, they only hire like a local because their English is not good. Okay, but I think probably there will be more positions later on. Okay, for like companies like Garmin, okay, or like Delta or some other companies. Okay, so if you're interested, you can try to like contact them directly first. Okay, after like the second year or the third year of your undergraduate study, and if they are happy to hire you, then it will be more efficient for them to sign a contract with the university. Okay. Yeah. So these are I actually visited them one by one. Okay. This is from like 2018 after I joined our department up to now. Okay. There are actually more than 10 students. Okay, but I just listed some of them, which I think is more important. I mean, the more important company, not the more important student. Okay. Okay, so in part 4, let me talk about the research environment. Okay, so just briefly let you know that we have 11 public labs. Okay, equipped with sophisticated instruments, such as this is a TEM. Okay, this is newly bought TEM like 2 years ago. It costs like let me see, $2 million US. Okay, that's 60 million Taiwanese dollar. Okay, NT. Okay, and we also have a scanning electron microscope. Two, actually we have two. One is older, one is newer. Okay, and we have two TEM. This is a new one. This is the old one. And focus ion beam is when you try to use ion beam to try to do some micro machine. For example, if we want to cut a line on our sample with only like 1 micrometer or 2 micrometer in width, we cannot use a knife, okay, because the knife is too thick, right? Okay, so we try to use ion beam instead. Okay, and this is also used to prepare the samples required for TEM. Okay, to prepare the sample, you can cut the cross section of your device or your sample, okay? And if your sample has different layers, it will be clearly observed inside the TEM, okay? Inside the TEM. And these are the XRD for material analysis, okay? So these, we have, if you go to the material science department, in any university in Taiwan, you will look something is quite similar to us, okay? So in the past, we might not have these many instruments, okay? But recently, we come up with a more complete collection of these, okay? So it becomes more similar to the normal material science department, okay? For us, okay? And this I talked about this before. This is a 3D printing lab, okay? So many mechanical engineering students came to do various projects. Okay, so I think this actually is more related to mechanical engineers. Okay, because in order to use this type of printing systems, okay, you need to be able to draw the 3D model or the 3D pattern of what you like to print. Okay, and it will be much easier for the mechanical engineers to draw, to come up with these various type of design. Okay, so it doesn't matter what department you belong to. Okay, you are always welcome to talk to the lecturer that is responsible for the 3D printing lab. Okay, the lecturer responsible for this lab is Miss Huang. Okay, and she's very nice. Okay, she's very nice. Especially she's also in charge of the international student affairs in our department. Okay, especially for graduate and PhD student. So she may know more about the issues related to international students. Okay. And last but not least, okay, I want to talk about the career plan for the graduate student, okay? Where did the students mostly go after they graduated from our department, okay? They mostly go to study master's or PhD, okay? Among the almost 72%, okay, continue their study, okay? And almost 68.7% study in local graduate institute, okay? This means that they go to master's or PhD studies in Taiwan, okay? And 3% go to like United States or Europe to continue their study, okay? And 12%, about 12 to 15% every year go to work directly, okay? And about 7% go to military service. But for this I mean short-term military service, not the long-term one, okay? And other means that they're preparing for any type of exam or the position offered by the government, okay? Position offered by the government, okay? So mostly continue their study, okay? And after they graduate from like a master or PhD, I think over 70%, okay? Maybe more than 80% go to the semiconductor industry, okay? So I didn't put Micron here, okay? But mostly the students graduated from master in the material science department. They will be likely to go to TSMC first, but maybe after a while they think the lifestyle is not what they want. Okay, they go to other companies. Okay, because in TSMC the work hour is long, right? And you are not allowed to take your cell phone inside. Okay, so these are, I think, the two most troubling issues, okay, for them. Okay, and so some people may even go to like the display companies such as Electronics or the one in the southern part of Taiwan. I forgot the name, the English name for it. Okay, Chunchong. In Chinese called Chunchong, but I forgot the English name for it. Okay, and if I think for most IATP students, your English would be quite good. Okay, so you can consider a small applied materials, LAM, or other international companies. Okay, and it will be easier to achieve a work-life balance. Okay, in these international companies. Okay, so I think I will finish my talk here. Okay, so good luck to you. But before I end, I want to ask another time. Okay. How many of you will be interested in selecting material science as your major, okay, after this talk? Can you raise your hand? Okay, still 0, that's good. It's okay. I can totally understand, okay, because when I was in undergraduate, I don't know what interests me, okay? But maybe in the future, if you need any help or support, okay, or if you want to, before you graduate, you're interested in go to material science related department for your masters, okay, you are free to contact me at any time, okay? Okay, thank you, and then see you soon, okay, bye bye.